Well, good morning, good afternoon, everybody who's interested in Spotfire and TIBCO Analytics. Welcome for another installment of our TIBCO Analytics Meetup. I'm here today with the TIBCO Data Science team, and we're going to take you through some new developments. Just a reminder about the Meetup. It is fairly new. It's growing, so tell your friends, join the group, receive automatic invites to the future Meetups. Updates on all the meetups and the presentations. You can email the meetup to suggest topics, that sort of thing. And this is part of a series of Spotfire contacts that we have through the TIBCO community, including our popular Doctor Spotfire session, our bi-weekly introduction to Spotfire webinar, our newsletter. All of this information is available on the TIBCO community site, which we'll give you a tour of at the end of today's presentation. So I'm going to kick off with a little bit of an introduction to machine learning in Spotfire, and then we're going to have an example of machine learning from David, one of the data scientists, around the use case of anomaly detection. And then Peter's going to give an update on our Geo-Analytics work, demonstration and new community content, and Helene's going to wrap up with an update on the community. You can submit Q&A at any time through the Q&A option, and we'll either answer it in context or via email. So just as an introduction to machine learning that's in Spotfire, as you know, there's an inbuilt, folks who've used the Spotfire know there's an inbuilt tools menu that has a number of machine learning type functions in it, including classification, regression, clustering, line similarity, data relationships, things like that. So the out-of-the-box tools menu has some simple-to-use point-and-click functionality for creating models. Secondly, when you go into the expression area to create an expression, that allows you to create an expression in R directly inside of Spotfire, and those calculations display automatically and are refreshed, for example, on maps or on graphs or axes. And then finally, data functions where you can include R code or even SAS or MATLAB code and map the arguments of the data function to the columns of your data in Spotfire, and then push the output back as a Spotfire table or lines on a graph, that sort of thing. So 3 levels of interaction for you to create your own smart analytic apps, your particular applications. And the way we support this data science inside of Spotfire is, firstly, we've got an embedded R engine right inside of the Spotfire analyst and also on the Spotfire server that allows you to embed your own R functions in your work. Now, there's a collection of R functions on the community site that you can just import and point and click your way through. And the idea is that there's only probably a few people who write the R code, but a lot of people can benefit from the R code. And one of the ways that those folks benefit is when you save your Spotfire application to the Spotfire server, it automatically gives you a link to share with your friends, a link to that analysis that they can run through the web, or embed that link in another portal. But basically, a large community of folks can access that analysis in a web client, point and clicking their way through it. So that allows mass communication of the data science or analytics work across the organization. So a small number of data scientists can have a very big impact on a broad organization. Now, also the data functions that I mentioned, they out of the box come. You can write your own R code or bring in someone else's R code into a data function, and the TIBCO R engine is installed with the product on the server and on the client. But also on the server, you can wire up the stat services to another engine. In particular, a lot of folks use MATLAB with Spotfire. Some use SAS with Spotfire as well. And then the Spotfire library manages components for reuse and sharing. So as you create a function or a connection to a data source, or you style your dashboard, or you know, a variety of things that you do in Spotfire can be saved off as an artifact in the library for you to reuse, or for folks who have access to your library to reuse. And then finally, the TIBCO Community, which we'll show you today, has a pretty large collection of data functions and templates that you can bring into your library or share with your organization or use personally. So the TIBCO Exchange and also our partner exchange, Exchange.ai, have those components that you can use to supplement your own library. So what does this TIBCO Runtime R engine do inside of Spotfire? You can right-click on some graphs and you'll get calculations done using the TIBCO R engine. For example, a forecast done on a line chart. As I mentioned, when you go inside of the expression area to wrangle your data, you can use the inbuilt expressions, or you can write your own in R and save those off for reuse. I mentioned the data functions, and then the predictive modeling tools on the menu, and then you can also extend the palette, the Spotfire graphics palette with R code. So here's an example of a data function where I use the R function contour lines and push the results of that back onto a Spotfire map chart. The Spotfire map chart can accept a binary object coming back from a TERR data function and display that directly on the map. And then you get to point and click to style the lines, color them, change their thickness. It's all part of the Spotfire experience, but tightly integrated and supplemented with a data function. Now, those data functions can be configured to do a whole host of things. In the semiconductor industry, we have data functions that you give the width of the die and the height of the die, and it'll construct a wafer map chart for you. And now that chart then becomes part of your regular Spotfire charts, and you can do all the usual things with that chart, including you can do a smoothing function on top of the intensity of the pixels. In the top right-hand corner here, you see a smooth representation of the yield at the individual chip level across the wafer. So that smoothing function is another data function applied to the intensities of the chips. So these types of configurations can extend the graphics palette in some really nice ways. And you know, like I say, once you have that representation of through a data function of a wafer map, you can do all the usual things in Spotfire with it. You can have multiple of them. You can trellis them. Bottom right-hand corner here is a trellis display of multiple of those wafers. So now as I highlight in the top left-hand corner areas of low yield, that will show up on the chips and vice versa. In this particular case, I can see this red pattern around the circumference of the wafer, indicating low yield at the edge of the wafer. So those chips on the edge of the wafer have a low yield, and that's a pattern that you can use to detect you know, anomalies in you know, of chips on the wafer. So by various displays, you know, visual displays, you know, the wafer maps in the bottom right, the trend in yield as a line chart on the top left, where you're highlighting the low yield, you know, box plot. There's lots of ways of exploring your data to highlight outliers and spot the fire in your data. David's going to talk today about anomaly detection, and this is another data function that we're using the R interface to H2O to go and do some deep learning to figure out what points are anomalous compared to the rest of the points. David's going to get into detail about this, but you can get these early warning signals about when a piece of equipment is going to start to degrade in its service or potentially stop. So these sorts of functions are available on our community site. We've got you know, boosting and random forest through this deep learning anomaly detection. There's a variety of templates and functions for customer analytics, segmentation, propensity, affinity, and that collection of functions is growing. If there's something you're looking for that's not there, let us know, and also feel free to contribute back to that community. Now, this ability to do data science is part of what we call the TIBCO Insight platform, where you're using Spotfire to do data discovery, to find an insight, accessing the data, wrangling it, analyzing it, coming up with a model, and then deploying that insight to make a prediction, to take an action, and then monitor the results. This is where we combine our Spotfire product for insights with our stream-based product for real-time streaming analytics and intervention. So this is something we've been pretty excited about. We've got a number of applications of folks fusing our visual, predictive, and streaming analytic technologies into this closed-loop solution with continuous learning and updating for key business applications, and it creates an enormous amount of value as you start to automate and support decisions that are important across real-time data. Not sure how far David's going to get today, but in that context of the anomaly detection, after you visualize the data and come up with the model, you can then start to score live events on that model and take an intervention or an action before the equipment degrades too much, before there's an outage, for example. So that's an example of the Insight platform. There's a whole community page, dedicated to this, a number of articles and use cases and so on. So we want to refer you to that. So with that, as an introduction, I'm going to hand off to David to get into the first case study around anomaly detection, and then he'll hand off to Peter on the Geo-Analytics, and then come back to Helene for the community update. So David, I just pass the ball over to you. David, you have to unmute yourself to speak.
Can you hear me?
Yep, can hear you now.
Yeah, okay.
You have to share your screen.
Okay, can everyone see my welcome screen? This is
yes.
This is David Katz. I'm a consultant in the data science group, and I'm going to talk about anomaly detection, specifically using a technique called the autoencoder, which is a type of deep learning neural network. So I'm going to start by talking about the one of our use cases, and then show you the template that we use to do this type of analysis, and then I'll also go into other use cases as well, because anomaly detection is useful in a lot of different contexts. So let's get started with this particular challenge that we had. We were working with a large organization that did internet providing, video on demand, telephony. They had a large complex service provider system, and sometimes they would have problems, and the problem was they didn't really get early warning. The first they know that they're having a problem is that the customers call in and tell them that there's an interruption of service. So what we were looking for was a way to detect the problem sooner. And in order to do that, what you really need are two things: is timely alerts that something is wrong, and then cause analysis to help them, help guide them in fixing what the problem is. And this has very broad applicability in Internet of Things, manufacturing processes, and so forth. Let's look at the current environment that we started with. basically, the small print over here is somewhat unreadable log file, and these log files have a lot of information in them, but they're not user friendly. They're user hostile, one would say, and basically what you get is a situation like this where you have a lot of information but no understanding of what's going on. So the first thing we did was we used an R script as a data function to parse this information and make it into tabular form. So there are all different types of messages, and the messages within those types constituted the rows of the data that was going to go into our analysis. So here's one of the templates that we use for this, and basically you can try and visualize some of the data, but the point here is that you would select the variables that you're going to use. So you know, in most cases you would use just about all of the data. Because we're talking about an unsupervised learning situation. We don't really know. We don't have an outcome variable that we're looking for. We're looking for some kind of anomaly that is atypical. So actually, the anomaly detection in deep learning is in a sense an extension of principal components, or clustering approaches. Also, where you can say, okay, here are some typical clusters or typical components that highlight the data points that don't fit into that. So the autoencoder is not a new method, but it's gotten a lot more available and useful. It's used in a lot of different ways, not only for anomaly detection, but for data compression. It's used for pre-training deep learning networks, where you've got the ability to pick out features that are specific to your data set without any pre-knowledge of what that's likely to be. So here are some of the applications of anomaly detection. We'll talk about those, but this is a simple autoencoder might look like, and the description of it as an autoencoder means that what you're trying to do is replicate the input as closely as you can as your output, but doing it with a kind of dimension reduction or you know, some kind of way that reduces the degrees of freedom, because you've got in the neural network context, you've got a limited number of neurons or nodes in your hidden layer, and we'll see later that it can get a little bit more detailed in terms of the features you can extract by having multiple hidden layers. So we use an R package provided by H2O. It's an open source R package, and it's got a lot of advanced analytics in it and deep learning in it. The deep learning function has an autoencoder ability or option, and this is kind of the architecture that we use. The user would typically see Spotfire as the interface on the desktop or the cloud implementation or using the web player. It communicates directly to the TIBCO Enterprise Runtime for R, which Michael talked about to some degree, and that talks to the package. Of course, you know, a lot of the power of R is in the wide variety of packages that are available, and those, of course, accessible and usable by use of our data functions within Spotfire. So one of the nice things about H2O, the package will run on a server, on your desktop, or even on a Hadoop cluster. It can be configured to run on rather large data. So here's part of the interface that we developed, which is just a way of specifying, how many hidden units you want in each layer, and some of the other parameters that go into training a deep autoencoder. There's a lot of parameters that are available, but we were able to pick out a few that make it easy for the user to just do this from a Spotfire interface. Here's another example that shows, as I mentioned, multiple hidden layers, which enables the recognition of more complex features to be used in the autoencoder. And this interface actually accommodates that. You can just list several hidden units, hidden layers separated with commas, and go ahead and tell H2O to create a more complex autoencoder. So this is an example of the output from the autoencoder, and basically it's a histogram showing how well the autoencoder is able to duplicate the input. So the way I often think of this is, if you compress a photograph and restore it, most of it looks good, but some of it is fuzzy. And what we're interested in really is the fuzzy part, where the reconstruction error is large, or you can think of that as an index of how anomalous those points are. So here we see most of the points are on the left-hand side with a very small error. So you can think of those as being typical. And that as the error index increases, you have fewer and fewer cases. And so what you end up is with kind of a long tail. And then a typical thing that happens is that you get a bump where you get into not just a long tail distribution, but really things that are anomalous, and there are maybe a little bit more of them showing up. And those are the ones that we're interested in understanding better. So Spotfire, of course, lets you drill down and take a look at what variables and what values are associated with those outputs. Marking those points in Spotfire, you have it configured in such a way that you drill down and get this detailed information. And that guides you to tell you what's going on. Here's another view of the same data. Again, here it's a time series view, and the reconstruction error is on the vertical axis, on the y-axis. And you see on the left-hand side, there are a few, examples of the long tail. But again, the ones that we've marked over on the right-hand side, Spotfire lets you code that as a color, and you see it very clearly in any case that gradually you start to see these log entries that are not typical of what happens when things are working properly. That gives you an opportunity to take action and start to solve the problem. So here's just another example of ways that you can display the different types of warnings that you're getting, picking, out of the maybe tens of thousands of different types of messages that you can get. You've got a good view of what the most important ones are in these atypical cases or anomalies. Another thing that we've experimented with is to use other machine learning techniques as a second step. So this is an example of taking that reconstruction error and then running a supervised version of the analysis. So now you have another way of computing this index and recognizing the upper right-hand corner where you've got a high index of an anomalous situation. Now, why would we do that? Well, although you can get this directly from the neural network, it's actually a lot more efficient to use this gradient boosting machine, or GBM, to get this type of variable importance plot. You know, some of the other advantages are that that can help when you move this to our streaming product and use it for online detection of these anomalies. The GBM function is a lot faster, so that can help speed up the ability to monitor huge amounts of information coming in. So let me go to just a little bit of a live demonstration. This is an example of a template where we used this technique of unsupervised learning, even though we knew what the target was. This is a fraud application using healthcare data. And we actually knew that which ones eventually turned out to be fraud, but we didn't use that information in the autoencoder. So what we see here, we can take a look at again, these are two histograms. So this top histogram, you know, we've cut off the top, but you know, so we have a lot of cases with a low error rate, but the coloring in the lower part shows that the small number of cases that had a very large reconstruction error had a very high percentage of actual frauds. So we see, you know, in the case of the low reconstruction error, there were hardly any frauds, and we considered this a very good validation of the technique because we were able to find this with unsupervised learning and still, you know, match up the later information about what was actually available. So these we have this specific version of the autoencoder is available for download. I'll show you how to do that in a moment. That's on the community site. And it has complete instructions on how to install the packages that are required. It enables you to import your own data and do some selection on it, and you know, use this type of interface to you know, to send parameters to the H2O anomaly detector, and then to take a look at the results. And again, here we see a histogram, and as you mark the histogram, see and you can see that these problems seem to come in waves on a periodic basis. So let me just quickly show the community site. This is community.tibco.com. I think there's going to be some more demonstrations of it in detail, but just to show you where you can find this anomaly detector as well as other ones, you go to the Exchange, and you have a large list. You can filter and search the list, and here is the anomaly detector. So you can just select whichever one you're interested in, and you go to the Releases menu, and you can download it, and it's ready to install. So I think my time is up, and I'll turn it over to Peter. Peter, you ready to go?
All right. Yep. Thank you. See if I can share my desktop here. All right. Thanks. So I'm Peter Shaw. I'm a data scientist in the data science group, and I'll be talking about a couple Geo-Analytics applications, downloadable examples on the Wiki site, as well as the updated page on the Wiki that talks about Geo-Analytics. So here's our TIBCO Community site, as David just showed. If I first navigate to the Wiki, I'll show you the updated page on the Wiki. So here's the Wiki site. Go down to the Spotfire section of that, and inside the core capabilities here, the one on mapping is what I'm going to basically navigate to now. So this is the page that has been updated. A few more sections added to it. There's a table of contents here. It starts with some of the starting the sort of core skills, the core tools of how to use maps, how to put layers on, and so forth. There's the next steps of visualizations of, there's some recordings of past presentations and so forth, and it goes on to the Geo-Analytics, which is a cloud-based tool to do geocoding and routing and so forth, and it talks about additional tools here. There is a scrolling kind of a slideshow, talks about each of the different sort of number of examples here. If you click on this thing, it actually takes you to a gallery itself, which in turn links to relevant assets. So if you see a example that you like this WMS or TMS thing to show topography and some weather, you click on that. So any of these things are actually clickable links. Actually, many of them, are clickable links, so it takes you to that asset. So to go back to the this locations analytics website, the Wiki page, again, the beginning section here talks about things like how do you add a marker layer, how do you add a feature layer. If you have questions about the TMS or WMS layers, it's all explained here. These link back to the TIBCO Spotfire help page, actually. There's a series of these quick reference topics which talk about a number of things. These are extremely useful. There's a number of videos on these charts and so forth. And here's the next step. So this section here talks about the types of layers you can add. Really goes into all the detail there. Here's the part on the web-based part, the geocoding, if you want to do route calculations and so forth. The geocoder, the reverse geocoder, batch, all this kind of stuff. These are all links to take you to each of these topics in detail. As far as the more topics goes, this is where we get into some of the assets on the gallery. Here's a little animation here showing how to use some of these things. I'll be actually talking about this in a bit more detail shortly, but there's a series of these downloadable assets you can get to on the community site itself, and I'll be actually walking through this one right here in a moment. So a couple of new ones are the Spatial Heatmap for Spotfire, as well as the Spatial Density Plot. And this listing right here kind of shows a lot of the different geospatial kind of assets we have. So we've had the map contour plot for a while, the hexbin data function, as well as points and polygons. These more recent two things are sort of the kind of updated versions of the map contour plot. So it's the map contour plot as well as this sort of a heat map in the background. So you have the contours you can see here, and you have this colored heat map shows up as a layer. You can actually color code that. So I'll be talking about it in a second. And then there's a few other links here at the bottom for the links to other community articles. All right, so let's actually go to the examples you're going to show. I could actually click on this, but I'd rather actually just show you how to navigate there directly. So here's our community site again. I was just on the Wiki page just then. I'm actually going to go over to the Exchange now, which is with the downloadable assets. So if you go to Exchange, focus in on the Spotfire part. Again, this is exactly what David just showed. So here's David's autoencoder, and here are these two new assets, along with all the other goodies we have on the site here. So if I click on the spatial heat map data function, what we have is basically it's a zip file which contains both the data function itself and a example DXP file. Now, to get to the actual download, you need to go to this releases link right there. So if I click on the releases, it takes me to an area I can download this zip file. So that's how you actually get the zip file. After you open this up, you're just going to jump right there. You get, so here's an example of the DXP file, which shows the, the data function embedded in there and shows how it's actually hooked up and everything. So if you want to study that, you can study how it's hooked up. There's a bit more information about where the data come from. This is actually NOAA data. This data set is NOAA data showing a snowfall event in March. I think it was called Stella, Winter Storm Stella, that dumped a huge amount of snow back in March on the East Coast. Let me just talk about the other one as well. So there's two in play here. So there's the heat map, and the other one is the density plot. So density plot is where the actual locations themselves of the things, of the points are important. So for example, in the city map, you might have a listing of, traffic accidents. So the locations are important of the traffic accidents. This one in particular just shows population centers of the U.S. So it kind of shows you where the populations are. And the, so if you have a map of the city, you might have a heat map of the locations of the traffic accidents. That might tell you where the busy intersections are, or it might tell you where the most dangerous ones are, clearly. So the other one, that was the density plot. The heat map, this actually shows the measured variable. And I think to best illustrate that, I'm actually going to show you a live example. So here's my live example. Here's the actual underlying data from NOAA. These are actually observation stations. We have a latitude, longitude, and this value here is the value of the snowfall in a certain 1 or 2 day period back in March when that Stella storm swept through. These NOAA data have a lot more information, the humidity, wind speed, but it's kind of filtered down just to the snow for that period. Now, to put this on a map, it goes to map visualization, and it'll discover latitude and longitude and make a nice map of locations. And it's also put a sizing by the value being the snowfall. I can also color by the value to kind of show you a bit more where the patterns are. So here's the underlying raw data that went behind that example on the downloadable site. So you can see the larger blue areas there are where the snow is falling. Again, the density plot isn't really applicable here. The points are the locations of the weather stations. So it's interesting, there's some cluster here by the National Center for Atmospheric Research in Colorado, in Boulder, Denver area. There's some clusters here, but the actual thing we care about, perhaps in this case, is the snowfall. All right, so let's, and the thing is, if you look at the individual points, the fact that they're individual points kind of masks the overall pattern. So you're trying to generalize this observation to look for the overall pattern, irrespective of where the actual literal points are. So we want to apply the smoothing and get a heat map of the patterns here. So I'm going to go through all the steps here. I've downloaded the data function. I've had that available. So if I go to my insert menu, go to the data function from file. I've actually got both of these here, the density plot and the heat map. So I'm going to choose the heat map SFD function, this Spotfire function definition file, open this up. And it's asking me for X, Y, and Z. X and Y are just location, so X I'm going to use the longitude, Y is I'm going to use the latitude. Z is the third variable to plot as the colors or the contouring thing. And for this, I'll choose this value, which is that snowfall value. Smoothing scale, I'm actually going to create a new document property, just call it smoothing. Make it a real value there, and put in, let's say, 0.2 here, just as a smoothing thing. And when I'm done, it'll produce 3 data tables, a heat map, contours, and the major contours. And if I just let it do its thing, it's going to go in the background, and it's done, although you can't see it because it's just produced some tables there. To use these on the map, these are produced in the TIBCO R, and to put these onto the map, I'm basically going to go to the heat map, and for example, so here's the heat map part, and I could drop this into the, this actually goes right into the, this area on the visualization, which allows you to put this geometry in. And initially, it's not very impressive, but if I go into the settings here, and I should wrap this up because I'm getting close to my time here. What I can do is I can begin to change the appearance, and let's change the border to 0. I can make it a little bit more transparent, for example. I can set the coloring to pay attention to the value, and all of a sudden I'm getting something which looks a bit more like a heat map, all right? And to, obviously, in a lot of the areas of the U.S., there was no snow. This is a snowfall event. So what I'd like to do here as well is go into this level and actually just trim off the areas that have no snow, and that kind of collapses it down. I can also turn off this actual observation just to focus on the actual heat map here. To put some contours on, I can just go to this contour table and again grab this geometry component here, drag us into the visualization. Again, this one piece lights up, which is the geometry thing, and it knows about the contours. So the contour also puts this outer boundary there, so I can get rid of that by I basically code that as empty, so I can just get rid of that by deleting that empty value. The major contours similarly are done by dragging these on. These actually, this is sort of like tick marks on an axis, right? So major and minor tick marks. I forgot to turn this off, so do that again. These have fewer values, so what I can do for the major contours is if I change the settings here, make the colors, you know, black to make a bit more emphasis there, and the appearance, make the line weight a bit darker there, sort of emphasize that. So here I have the overall. I basically reproduced the thing apart from the you know, artistic color scheme I used before, but you know, this is the basic color scheme, the basic heat map there. And I can go into I put the smoothing into a document property, but in the interest of time, just kind of basically not hooked up, but I could hook that up and you know, have that a live, you know, as I refresh the smoothing, it would be a live you know, changing visualization here. So, all right, so that's basically the heat map data function. There's a whole, you know, I would encourage you to explore this this new web page on the Wiki site to look at all the other components there. If you ever wanted to learn about some of these features, the WMS or TMS layers, that's a great way to do it. So that's my part. I think I'll pass the control back. Pass it on to Helene.
Great, thank you. I'll be sharing my screen. Okay, great. So I'll wrap up our session today with a reminder of the TIBCO community, a reminder of the TIBCO community and the various ways that you can interact with the TIBCO team and learn about Spotfire. So there are many different ways that you can do that. The main thing that you've heard over and over in this session and in the previous session is the TIBCO community. That's really the platform for our users. So community.tibco.com, and you've seen us use a number of the key segments of the community, which are the exchange and the wiki that you've seen today. But there's also an answer section where you can ask questions. There's an ideas section where you can interact directly with our product management team to submit ideas for improvements to the products or suggestions that you have, or vote on existing ideas that your peers in the industry have already suggested. So just to put a little bit of context in the different ways that you can interact with that. So all of you that are joining us today have registered for the online Spotfire user group, which is a meetup that provides virtual meetups like this TIBCO Analytics Meetup. The target for this Analytics Meetup is really for existing Spotfire users, so a lot of data scientists and analysts that have used Spotfire for a while and like to learn more and take full advantage of the assets that we publish on the TIBCO community, join these sessions. We also create recordings from these webinars, so they're available on the community. We share them through the meetup, and they're also available on YouTube. So we're trying to make them available in many different ways, so you can find us quickly when you would like to learn more. There's also Doctor Spotfire, which is a session that runs more frequently, and it's really focused on your specific challenges with building analytic applications. So when you get to using Spotfire and you're trying to do something but it doesn't quite work, there's an opportunity to ask your questions through the community using the hashtag of Doctor Spotfire, and we'll be using the questions that are posted on the community to run these webinars and answer your questions there and then live in the webinar. We can even use your data if you prefer to do that. So this Doctor Spotfire session is much more focused on your specific questions that you have about using Spotfire. If you're new to Spotfire, and if anybody is on this webinar today that's new to Spotfire, the best thing is to go to the Spotfire website, which is really focused on newer TIBCO users, download a trial version, and also participate in our regular Spotfire demo webinar session. So I put a link on here as well. We'll be sharing those slides as a reference for you, so you can go back and use all the links. Another thing I wanted to highlight, and again, you'll see some repetition here because we find different ways of communicating with all our users, but there's also a quarterly Spotfire community newsletter. You can sign up either through our website or through the TIBCO community, so you'll find us either way. Once you're signed up, you'll receive the quarterly update, and in this update, you'll also be reminded of new content on the community, new features of a new release, events that are relevant for you. So another way and another frequency for us to communicate with you about the great new things about Spotfire. I wanted to use a few minutes to highlight some updates on the TIBCO community available for you. You've seen a number of them today. I'm actually going to show the pages, and thank you, David and Peter, for showing some of the pages already and how to navigate, because that's usually the trick, is you just need to find your way on the community. On the right-hand side, you see the example of the main Spotfire community page again, and I'll show some examples. So this is the new content that Peter started with, so the link is on this page for you as a reminder. Major updates from maybe what you've seen last month, so really useful and very practical tips and tricks and downloadable DXPs and data functions for you to try at home. Then the actual data functions on the exchange, which Peter has also showed how to download, and the link here again as a reminder. The Anomaly Detection Template that David showed us with the link again. Some random forest templates, Michael mentioned these as well. They've been recently published. We'll probably use the next TIBCO Analytics Meetup to explain these in more detail. There's a new CPG and retail industry page. So besides the sort of the product-specific information, we're also trying to link the various tips and tricks and customer stories and use cases to industry. So you'll find pages on FSI, on energy, on manufacturing, and now also on CPG and retail. So take a look at that as well. The TIBCO Insight platform, as Michael mentioned that at the beginning. So how are we putting how we're using our historic data to create a model and use that in real time with real-time data to identify the events that really matter, whether that's in promotions or identifying promotions, or whether it's in production, trying to avoid a machine from breaking down, or detecting fraud. There are a lot of examples of how this TIBCO Insight platform works, and also how it pulls the different pieces of software from TIBCO together. So you can find that on the community as well. And a reminder on the Big Data Wiki page. This page has actually existed for a long time, but we keep updating it because it's so relevant for all of you. So this is where you'll learn how to use Big Data and Spotfire for visualization, for data discovery, but also for advanced analytics. You can find the white papers explaining how to use Spotfire with data in memory or on demand or in database. So please take a look at this as well. And we keep updating that as we learn about the questions that you post on the community and in the various webinars that we host. We talked about extending Spotfire in our previous TIBCO Analytics Meetup, and we've worked hard on that since then. So there, again, has been a lot of new pages and scripts released for your use. So all of those are also in the on the community wiki, and with the scripts that you can just copy and paste and use in your analytic application. So we had a lot of demand for this, so hopefully you'll find this useful, and we look forward to hearing your feedback as you start using them, and any requests for further scripts that you would like to see, please send them to us. And then, of course, whenever there's a new release of Spotfire, and we have frequent releases now, so when there's a new release, this is where you'll find all the detailed information. We often post videos and tips and tricks on how to take full advantage of the new capabilities that are released. So that's available to you as well. And then we're also trying to organize the tips and tricks from sort of a tips and tricks homepage. So a lot of the things that I've talked about are tips and tricks, because the community wiki is really for our users and to explain to you how to use Spotfire. But you can also navigate starting from a tips and tricks page. And we often use these at our Spotfire meetups that we host in our various offices. So when we share new tips and tricks, we post that information on the community as well, so that everybody globally can benefit from that, even though it was demonstrated maybe at the local meetup. So talking about local meetups, so besides the virtual webinars and the virtual TIBCO community that's available to you, we are also at many events, either sponsored by TIBCO or in our offices, or specific events on big data or predictive analytics or otherwise. There is a page on the TIBCO community that navigates to a main TIBCO software meetup page, and it automatically links to your location, so it will indicate where the next meetup takes place. So if you'd like to meet some colleagues in person or meet TIBCO experts in person, this is a great way to sign up and get connected. So I recommend you take a look at that as well. And a very good meetup is coming up, the TIBCO Now conference. This is our annual conference. Last year it was in Las Vegas. It was a global conference. This year we have a regional approach. So the Singapore one has just finished, which was a big success. And the Berlin conference is coming up. And San Diego, you can also sign up for already. So all the information is on now.tibco.com. For those of you who've been at TIBCO Now events in the past, it is an event for our users to learn about TIBCO, all of the new Spotfire and other TIBCO software releases. We do demos, we do training sessions, we have customers talk about how they use our software and what the value is. We look at industry-specific applications, so there's a lot to learn. You'll be able to meet many of our team there as well, so we'll be able to meet as a group, and we'll make sure that we get together as Spotfire experts as well. So we look forward to seeing you there, and if you have any questions, just reach out or go on the now.tibco.com website to learn more. So that brings us to the end and leaves 6 minutes, Peter, for questions. I hope while I was talking that you have been able to collect a few questions from the Q&A or the chat that has been sent to you directly. I'll leave this slide up. If you could just call out the questions to Peter or yourself or me or Michael, we'd be happy to answer them.
Sure. There's a question about the autoencoder and the SNMP traps, and the question, David, is if that autoencoder is running live or it was trained on used data. I believe that's the question. So, do you have any comments about that?
Of the data that you give it. So I chose just to show some pre-trained models. You know, the mileage may vary depending on the data size, the parameters you use, and the resources that you throw at it. One of the nice things about using the H2O package is that you can configure it so that it actually runs on a cluster. It does the memory management across all of the nodes, and so you can get very good performance that way for your larger problems.
All right, great. Another question for me about the two new examples, the density and the heat map. The question is, are those two methods using this? Is the two examples using the same methodology, the same data function? And the answer is actually no. You get a very similar looking plot at the end. David, you're still getting some noise from me. There you go. Thanks. So those two examples, the density, they actually use two different methodologies. The density is kind of like a histogram, but in 2 dimensions, like a 2-dimensional histogram with a little bit of smoothing. So it's actually a kernel density estimation, technically, is what's going on. Whereas the snowfall example used a smoothing with a sort of, a heat map of a third variable. So there's two very closely related. They actually look very similar, but they're actually different underlying methodologies. So I thought it would be best to break into the two separate examples on the community site just to make that point clear. All right, Helene, here's one for you. Somebody wants to know if they want to monitor a topic of interest on the Wiki site. They want to know how they can tell if a new article that fits their interest is published on the Wiki site.
Okay, that's a good question. Actually, I'm just wondering, it might be best to show that on the community live. So here's the Wiki. We often get questions about, how do I find out about new things? So for Iron Python, for example, let me search for that. And maybe just a reminder as well, or not Iron Python, but searching is a really powerful tool on the community. So if you have trouble finding anything, use the filters and use search to find something besides the starting page for the Spotfire Wiki. So every single page, as long as you're logged in, so if you're a user to the community, if you've registered once, then you can log in and you're actually able to interact with all the pages. So every page has an option to watch. So if you click on watch, you can see it changed from the blue watch piece to this check mark, and it means that you're watching the page. So if anybody makes an edit to the page, then you can you'll get an email. So if something gets added, you'll know, and you can take a look and see what's next. And the other thing, I guess, is what we talked about earlier is if you have if you read the newsletters and attend these kind of webinars, you also get proactively notified of new content. So I hope that answers the question.
All right, that's great. We have like 1 minute left, so there's one more question about can Spotfire use the machine learning platform offered by Google, and what's the connectivity like between the Google Cloud platform and Spotfire? You want to take a shot at that?
Repeat the question.
I think you went. Can we talk to Google cloud platform machine learning. We have to actually wrap up. It's 9 o'clock, so we're basically out of time. So maybe we should defer. We'll probably, Celine, I guess we can answer the questions.
Sure, we can answer. We'll answer it through the meetup.
Remaining questions on email.
Yeah, if you can answer any questions either via email. You see the contact here on the slides, or in the meetup, and we'll answer it there. So thank you everyone for attending. We'll set up a next analytics meetup in June.